Our next speaker, Dr. Roy Beckford, is the University of Florida's Agricultural and Natural Resources Agent here in Lee County, Florida. He's also the County Extension Director. He's worked in Jamaica and the British Virgin Islands, and every day wonders why he relocated back to the United States. This morning's session, he is going to present his research findings related to using biochar for soil restoration and environmental management. Dr. Beckford? Yeah.
So good morning, everybody. It's always very difficult to follow Dr. Wilkie. And it's really because she has this wonderful accent. So I'm going to pull my accent out of the bag. I don't normally sound like this, Dr. Wilkie. I'm going to try my Jamaican accent today, okay? Well, it might be related, of course. I could talk for about 5 minutes about that. All right, so it's good to see so many familiar faces. ECHO is kind of like my second home. The fact that I'm an extension agent in Fort Myers, and ECHO is in my, basically really in my backyard, is a really beautiful thing. And when I say backyard, I mean that literally, because everything that grows at ECHO grew in my backyard in Jamaica. All right? So I've been very familiar with everything that grows there, and it's been a wonderful experience to work with folks at ECHO. And essentially, part of what I'm going to talk about today had a lot to do with the collaboration that I did with ECHO. And there are a few names I want to call: Craig Billima, Rick Burnett, Brad Ward, and there has to be somebody else, and Dr. Tim Motis, are people who contributed significantly to some of the things I'm going to talk about. I'll jump right into this. I'm going to talk about biochar for soil restoration and environmental management, looking at it from an integrated food energy systems approach. Most of the work that I did happened in Haiti, but I did some proxy evaluation at ECHO in the fuel wood plot there, and it really helped to move my research work forward, having ECHO there to kind of lean back on for some of the work I was doing. So in 1985, I was 19 years old, and I had been the recipient of a World Health Organization scholarship to go down to Guyana and study veterinary medicine. I was on a slightly different agricultural path, but I've integrated it so far. And I flew over the island of Hispaniola, which is right next to Jamaica pretty much, for the very first time. I was very struck by the image you're pretty much looking at, because it hasn't changed significantly in those probably 30 years or so. But it got me wondering, because none of the Caribbean civics lessons that I learned in school prepared me for the reality of what has happened and transpired over the centuries with Haiti. So I got very, very interested in looking at Haiti. Why were things so different there? Ecologically, why were things so significantly different, given that this one island with the Dominican Republic? So I kind of set off on a track over the years while I was doing other things to kind of go back all the time to Haiti and looking at the issues there. And I have come up with some ideas over the years that I thought was helpful to me in kind of resolving the conflict in my mind about why Haiti is the way it is. But more than that, I wanted to come back in recent years to looking at doing research that I think could be helpful to resolving some of the ecological problems there. I want to actually start by saying here that my personal belief is that Haiti's problem, Haiti's issues and challenges are not economic. I believe that Haiti's problems are ecological. All right, and certainly there are economic issues in there, but I believe that it's an ecological issue at the core. The reality of Haiti right now is that about 10% of Haiti's original soils remain. This has been this conclusion has been drawn from research conducted by Cornell University as well as several others over the years. Why is there 10% of the original soil remaining in Haiti? Because of the more than 1.5 centuries of erosion that happened as a consequence of a number of things that led to the removal of primary and secondary forests over the years. And 1% of natural cover as a result of the removal of those forests resulted in this soil erosion. And Haiti, as a consequence of this, has been named one of the countries least able to rebound from natural disasters and most at risk from climate change issues by the Climate Change Vulnerability Index. This was done in 2015. Let me do this quickly, and I won't spend a lot of time on this, but the first essential small community that Europeans set up in the West, based on the New World, was on a piece of Haiti called the smallest settlement was called La Isabella by Columbus. And of course, what happened when Columbus went back to Spain, the men at that settlement were murdered pretty much by or I suppose a better term would be eradicated by the Indians. And they set up another camp called La Navidad in what is now the Dominican Republic. But the first contact with the New World in terms of a settlement was actually done in Haiti. What does that mean? It can mean a lot of things, because that was the first place where much of the invasive species that dominated, some of them still dominate our modern Western world, landed. There's a great book by a gentleman named Crosby. He wrote a book called The Columbian Exchange. Crosby works at the University of California, and the Columbian Exchange actually looks at basically microscopic agents from bacteria to viruses to trees, to animals that were taken into this part of the world and were released on the island of Hispaniola and essentially spread out across the West Indies and the Americas as Europeans kind of set up camp everywhere else. But it's amazing that one of the things that he looked at, and I'll talk about that really quickly, a couple of things he looked at. One was that bacterial caries was pretty much unknown to this part of the world until the European contact with the Indians happened. And you know that from archaeological findings of what people's teeth look like. But for the first time, some of these Indians were seeing rotten teeth. Secondly, diseases like syphilis or strains of syphilis went back to Europe. So it wasn't simply a one-way movement of invasive species, it was a two-way movement that impacted both sides of the world. And you know what the issues and problems with invasive species are. From La Isabella, essentially what happened was the Spanish moved to what is now the Dominican Republic. But Haiti was ceded to France in 1695, and the French were very aggressive in terms of setting up cultivations and agricultural systems, pretty much managed by the labor of Africans once the Indian population were decimated, pretty much. And one of the base industry that they established in Haiti or in that part of the country was forestry, and then later they delved into coffee and other things. Eventually what happened was that Haiti became the most significant European colony in the world and was actually referred to as the Pearl of the Caribbean. All right? In the early 1700s, Haiti was the richest country, richest colony in the entire Caribbean and Americas. It actually outproduced what would eventually become the United States of America in terms of the amount of goods, the amount of agricultural biomass that were exported out of Haiti. Remember, Haiti is 1/3 of Hispaniola, and it was producing more than 1/4 of the entire wealth of France, and that happened for close to 100 years. Just so you know that, it was really everybody in Europe were absolutely jealous of France for the kind of wealth that was being pumped out of Haiti. I won't say anything about that reference by Thomas Jefferson to the ambassador, the French ambassador, Louis-André Pinchon. You can read that, what he said about Toussaint Louverture when the revolution started in the late 1700s. He actually pledged allegiance to Napoleon, essentially, that he was going to help him to make sure that he starved out Toussaint when the Haitians attempted to revolt from slavery. What has happened? What happened after Haiti got its, won its independence from France in 1804 was that by that time, a lot of its biomass had been drained, a lot of it. And it's Haiti actually represents the most mountainous portions of Hispaniola. And in terms of its ecology, it was absolutely delicate. And so by domino effect, what started happening then was that secondary forests were not growing back because the soil was eroding, and natural disasters actually created a significant problem as a result of the biomass loss and the primary and secondary forest loss, to the point where currently 37.4 million cubic meters of wood biomass, about 30 million trees are removed for fuel each year. Now, by the way, after Haiti got its independence from France, France actually forced, along with collaborators from Europe, the repayment, reparations for the loss of their slaves upon Haiti. They were actually charged 150 million gold francs, all right? And I always suggest that people compare that to the 60 million that America paid for the entire Louisiana territory, which is land from the Gulf of Mexico to the border of Canada, which comprises most of 15 states right now. So, but of course, this was a black country emerging in an era when there was slavery and all that stuff. So the point I'm trying to make here, and I won't go on further with that, is that the blame for the ecological collapse in Haiti has always been placed squarely in the laps of Haitians. And it's victim blaming. And there are lots and lots of books that have been written about victim blaming and how we need to go back and look at the issues that cause Haiti to be where it is, and how we can actually deal with the problems moving forward. It's interesting. I've been going to Haiti for a long time, for about 10 years, every year, several times a year. And there has been lots of tree replanting programs in Haiti at the rate of about 20 million trees with 40% survival rate. And people still go in there and plant trees and so on. But the problem is that there's been serious soil erosion. And I will explain why you have this massive survival rate or low survival rate of trees there. 3 trees per person are removed per year right now for energy. And the survival rate is less than 1 tree per person. So we're actually putting in more trees than we're actually gaining as a result of the issues. So the contemporary reality is that Haiti has just over 10 million people right now. 80% live below the poverty line. 54% live in extreme poverty, which is below the poverty line. I think I'm preaching to the choir. I think you're all aware of that. But subsistence farming is the main source of income for 70% of the people, particularly in the rural parts of Haiti. But 80% of domestic energy is derived from fuel, wood, and charcoal. Charcoal is used by 90%, even in Port-au-Prince. So the dependence on wood biomass energy is significant. This picture is from the city of La Gonave in that area there. These are canals. The picture on the right there is essentially a canal or a gully in Cité Soleil, Port-au-Prince. That essentially shows you lots of plastic bags, lots of soil that have been washed out of those mountains. So the erosion still continues to this day. Nothing, by the way, not much has been done to deal with this issue, which is massive. One of the things that I observed too while driving around Haiti over the years, and we doing all kinds of digs, roadside profiles were also important, is that there are lots of buried soils because some of these mountains wash down and they bury some really, really good soils. I'm not sure what folks can do with that, but that was I was interested in finding. Essentially though, currently what the situation is that more than 60% of Haiti's soils are deeply eroded down to the B horizon. And if you look at that, what you see is what a normal soil profile would be, where you have the organic horizon, your A horizon, B horizon, C horizon. What's happening in Haiti as a consequence of the things that has happened historically is that in most areas, particularly even in the agricultural areas, the soil horizons are down to the B horizon, which does not provide enough nutrients for trees to survive. Essentially, we go into Haiti, we plant trees, and we don't realize that we're not really planting it in real soil. So what do? You really have to find some way of dealing with this issue of soils in Haiti. Let me kind of compound the issue a little bit. The charcoal consumption chain in Haiti is tremendous. Charcoal is consumed, as I said, by 90% of the people in the city of Port-au-Prince and by a tremendous amount of people across the country. But here's the thing. The charcoal sector has never been recognized by anyone. All right, it's been mentioned by organizations like the Food and Agriculture Organization, so on, but it's a hidden sector, even though it actually employs more than 200,000 people in Haiti in the charcoal chain. People burn wood, they dig out tree roots, which they find, they chop it up, they make charcoal, they sell it, it's bagged, it's transported. It's a massive sector which no one has looked at really in a very serious way. So what I've done is to look at the three essential values, ecological values, economic values, and commercial values of charcoal. All right, looking in the areas in red, connote the areas that are deleterious to the ecology of Haiti. So from felled trees to tree roots, to deforestation, to soil and land erosion, and essentially the loss of agriculture and biodiversity, which leads to poverty. Poverty of soil, poverty of the ecology, and so on. But there are absolutely important components of the charcoal chain, which involves the process of carbonization, the number of people it employs, the artisans who make the charcoal stoves and all these things. The charcoal itself, the packaging, the transportation, the retailing, and the household and commercial energy it provides, which is a positive. And so I kind of looked at this and tried to establish research that would connect these issues, loss of soil, the charcoal chain, and see if I could come up with an integrated system that actually married the idea of food production with the idea of energy production to solve at least one little piece of the problem of massive ecological issues in Haiti. So it's interesting when you survey people in America. Actually, this word cloud that you see here was from 2 surveys I did in Fort Myers. I just asked people at one of my ordinary agriculture conferences what they knew about Haiti. And the words that popped out most often were, the reason Haiti is in the position it is because of voodoo. Also, it's because they have no trees. Generally they don't tell you why there's no trees, except that they chop their trees down. Issues like dependency, all those things, worship, damage, destruction. It's interesting that there is a lot of perception that is misguided and a lot of blame on folks who shouldn't really deserve it, altogether. So I delved into research, which led to a PhD a year and a half ago. And that is when I actually invited Dr. Tim Motis to be on my committee to help with some of the things I was looking at. He has actually done a lot of work in Haiti and other developing countries, and I thought he was really, really a good candidate for that. And I'm grateful to his help. So the 3 questions that I asked, and I'll delve into this because I don't want time to kind of run away from me, was that what are the dominant ideological biases that have constrained Haiti's social economic progress over time, and what mechanisms ensure their perpetuation? Why is it in most of our minds we think that the problem in Haiti is people are poor, they caused it, and the way to help them is to give them free stuff all the time without giving them jobs? To what extent are historical, ecological, and scientific factors contributive to Haiti's current environmental problems? And then, will an integrated food energy system, as defined by the Food and Agriculture Organization, where you integrate food and energy, even a farm, a very simple way could be growing fuel crops and growing food crops. There's not been in developing countries an ideological approach to getting farmers to understand that just as much as you grow food, you can actually grow energy. That is not an understanding that we have done. And we need to have actually a paradigm shift in the way we deal with these issues. All right, but anyways, and how can the model be demonstrated in the Haitian context? So here's what I did, and I'm just going to explain that. The first thing is I kind of conducted what I call a political ecology of Haiti's history, looking at the states of existence that Haiti has been through from 1492, from the arrival of Columbus, until 2015, and all the stages of underdevelopment they've gone through as a result of the loss of their biology, their major biogeochemical cycles, because once you start removing carbon from the system, you start ending up with major issues there. But also kind of juxtapose that with the ecological economy of Haiti that looks at the environment, the ecology, society, how they existed in that, and the economy, how it exists, and how that collapse has happened, and how there's feedback between the political ecology, as I show on the left side of that page, with the ecological economy of Haiti. So that I want to come up with a more holistic, a more systems approach to understanding the problems even better, and seeing if I could propose some process by which there could be some alleviation to some of the problems that exist. One of the things I do know is that there's some general natural biophysical factors that cause ongoing environmental loss in Haiti. It's topography, the soil types, and the bimodal rainfall. Rainfalls different times of the year, it gets dry, wind blows away the soil. All these problems needs to be understood so that the agricultural systems take advantage of that. And then there are some very serious anthropogenic factors, factors actually caused by people. The historical deforestation need to be put in context. Agricultural practice perhaps need to change. And charcoal production need to be examined, looked at to find its positives and its negatives and address that. Because it basically affects everybody's lives. Both the biophysical factors and the anthropogenic factors have led to massive carbon loss. And that, in my opinion, is the reason Haiti has never recovered, despite billions of dollars being pumped in there to support what is being referred to, not by me, but to support the poverty industry. That does enrich a lot of people outside of Haiti, by the way, and some in there. So the research approach, the integrated food energy systems approach that I took was, one, to come up with a way to restore soil. And how do you do that? There are various ways. The one I chose was to use biochar and compost as a blend to begin to repair the organic and the A and B horizons on farms. And the easiest way for me to do that, given the fact that I'm not a millionaire and I wasn't going to be funded by any of those either, was to conduct a proxy evaluation in Florida, hence the collaboration with ECHO. Then to continue to survey farmers in Haiti to kind of figure out where they are, what their thoughts are, and how easy or difficult it would be to kind of create that mindset of paradigm shift to moving towards an integrated food energy approach. Get farmers to kind of come up with their own ideas of their perception of the food energy ecology. What's happening? How am I being impacted? How can I actually make a contribution? And then to conduct in situ experiment in Haiti itself on farms to see how the biochar compost blends would actually work. And then evaluation of clean cook stoves for biochar production to make it a real serious circle when it comes to the idea of integrating food and energy. And I'll explain how we did that. First of all, an integrated food energy system is a systems approach, uses a systems approach. It doesn't look at the symptoms alone. All right? So you go to the doctor, you've got a big red spot in your eye, and he says, oh, well, I need to actually put something there to clear it up, right? And then he forgets that maybe there's a tumor behind it that I need to address, right? That is actually not a systems approach. A systems approach looks at the entire thing and deal with the issues, so you deal with the core cause of the problem and address that rather than dealing with the symptoms when they pop up. All right. So the integrated food energy system integrates, it intensifies, and consequently aims to increase the production of food and energy per unit of land by transforming the byproducts of the energy portion of the whole thing, or the food portion, into the feedstocks for the other, so that you have a cycle going. So contextualized to Haiti, this was the IFES that we looked at. One is what I refer to as restorative anthropedogenesis. And that's a big word, but all it means is humans making soils, essentially. All right? Using the process, using biochar to stimulate the growth of soils. And then secondly, to blend the food and energy farming, to look at that as an alternative to purely food farming. And then look at household sustenance. How does that impact in the food energy system? And then pyrogenic carbon, which is important to kickstart the process of growing soil. which is a major issue in the country. So the proxy evaluation in Florida at ECHO essentially entailed going into their fuel wood plot, removing some plants in there. Of course, what we have at ECHO is amazing because it managed to produce a lot of food on sand. All right, it's always been told that we don't really grow food in Florida the typical way. It's really hydroponics. You just put a lot of water and a lot of fertilizer in there, and the plants grow from water and fertilizer because the sand really doesn't contain a lot of nutrients. In most cases, less than 1% organic matter is in our sand. At ECHO, they do have immokalee sand, a blend of immokalee and mayaca sand there. So it's not really rich, and it's pretty acid too in many cases. Anyways, here's what we did. Applied a 2-inch coat of compost atop the sandy soil. And I will show you a chart of the very kind of complex plots that we did. But 101 pounds of biochar was required for each treated subplots. And we built Kanuka mounds. Now, Kanuka mounds are interesting because these are mounds that the Indians actually built in Haiti before the coming of the Europeans, where they built these mounds. And it comprised a lot of biomass and charcoal and a whole bunch of other things. And they planted cassava in these. And they would hold the mountains together so that there was not a lot of erosion on that side of the island before the arrival of the Europeans. But of course, European practice meant, you get rid of these people, you get rid of their trends and their practices. I mean, it's not all that important to look at. And I'm not blaming them. That was what was required for them then. We made biochar at ECHO. And some of you guys here might recognize these pictures from ECHO. So we use a T-LUD, a top-lit updraft system to make our biochars. And the biochar is essentially made by heating the biomass on the exclusion of air. The whole idea is to end up with pure carbon. All right. What is biochar? It can be broadly characterized as thermally modified biomass, but it is not charcoal in the purest sense of the word. Charcoal is made slower and more air goes into it and so on. And it, of course, it does not exclude air, so you don't end up with pure carbon in the end. Biochar is carbon rich, contains significant fractions of amorphous graphitic portions in tiny pockets and additional organic carbon properties. And the graphitic domains, the portion of that, within biochar has been documented to be stable in soil for millennia. We know this from some of the terra preta that was collected in parts of Latin America, Brazil too. The terra preta soils in Brazil made by the Indians, the pre-Columbian Indians, have been stable in the soil for a long, long time. Just quickly, biochar also has properties and molecular structures that resemble activated carbon. All right, which most of you are aware of. One interesting thing about biochar, activated carbon, is that it's a common industrial material that possesses these adsorption properties, and that's exactly what we aim for when we look at making and defining what good biochar is. Adsorption as opposed to absorption. Absorption is when you put a big wad of sponge in water and it sucks it up, it absorbs the water. Adsorption is like a ball of clay that you roll across sand and all the sand adheres to it. That's adsorption. All right? And every little piece, every little tunnel and hole and all these fissures within biochar has the capacity to adsorb water and nutrients, which is what it actually does in making sure that there is not just stable carbon, but additional inorganic and organic carbon that actually, well, that's kind of like crazy to say inorganic carbon, but we'll explain that in a little bit. The persistence of biochar is important though, because it's pure carbon, it has the ability to persist in the soil by not being susceptible to biological decay. That's why it's very important. And so you can see that if you actually practice this kind of thing, you'll actually be removing some of the carbon from the atmosphere. You have a way of sinking carbon, which is certainly an ecological approach to looking at dealing with soil issues. And soil, by the way, is a really important sink of carbon. We know the challenges that we have with atmospheric carbon. So the biomass is heated. And there are two processes in the creation of biochar that's important to look at. One is pyrolysis and the other is carbonization. The pyrolysis perspective actually looks at the chemical breakdowns that result in the liberation of pyrolytic gases from the biomass. And then the carbonization perspective focuses on the chemical buildup of the carbon atoms into solid structures, solid graphene structures, pretty much, which actually makes the carbon stable. The bulk of pyrolysis and carbonization reactions occur in temperature range from about 200 to 500 degrees Celsius. And one can think of pyrolysis and carbonization as kind of simultaneous physical chemical processes, which changes the biomass into pyrolytic gases and charcoal, or stable charcoal. So the biomass is heated essentially up to 300 degrees or more to end up with the stable carbon. The chemical bond modifications that happen consist of dehydration and conversion of these bonds, these carbon bonds, into various structures and so on, which makes it extremely stable. And this is a microscopic image of what pure biochar actually looks like. So essentially, you're turning biomass into stable charcoal or stable carbon. One important thing that I did for all the chars that I made both in Haiti and in Florida was to submit samples to Dr. Hugh McLaughlin, who's one of the gurus of biochar. And he conducted what's called GACS analysis, which is, it takes about 20 minutes to explain what that is. Essentially, though, he dehydrates the samples and then pumps radon through that to look at the adsorptive capacity of the char to see how effective or how stable the char is going to be. So those are some samples that I submitted. Those yellow lines are actually the range between really bad char and really good char. And so ours fell into a really good spot there once we started making them well. And remember the slide, because I'm going to refer to this in about 2 or 3 minutes. So the research plot is illustrated here. We did a whole bunch of tests and experiments. We had compost biochar areas. We had compost-only areas. We had char-only areas. We created Kanuka mounds. We had control areas and so on and so forth. In Haiti, one of the things that they thought was interesting was they actually, because they knew somewhat about chars, is that they added urine to charge the biochar so that it could be then applied on the farms and see how effective they worked. One of the things they actually did was to pile the char up, and we started seeing after several weeks that things are actually germinating and growing there. That is actually millet growing in there, and you can see the roots in there. It was amazing that in Cité Soleil we had an area that was absolutely green. One of the first things we noticed at ECHO, once we started applying these areas and making these grids of biochar compost, was earthworm activity. And it's interesting. One of the earthworm that we saw is an interesting one that you probably could go back and look and read up some more about, is P. corethrurus, all right? And asked me to say, well, the P is Ponthus colex corethrurus. But it was one of the worms that was attracted to the char. And P. corethrurus actually works in a very interesting way in the upper horizons of soil, in that they basically chew up the char, and then as they move downwards and across, they actually poop out these things. So you have veins of soil being incorporated in areas that you never had soil before. So as a consequence of the activity of these earthworms, we started seeing some interesting things at ECHO, which I'll explain about in a minute. Anthroposols, and here's where I come up with the term restorative anthropogenesis. Anthroposols are really man-made soils. This has been happening in history for a long, long time, not just in terra preta soils, but certainly in various parts of Europe. People, whether deliberately or not, by their activity, by laying down hay bales, by moving calcareous soils from one place to the other, have ended up creating soils in areas where the soil wasn't good to begin with. And they have created some really good things in various parts of the world. So the idea of creating soil is not new. Using biomass and other things. The idea of biochar is not new either. We have gone back to something that's happened 4,000 years ago that somebody invented, and we've kind of abandoned because we figured that modern science is the only science that there should be. At ECHO, we started out with about 2 inches of biochar compost and biochar and so on top of the soil. But within 12 weeks, with the, especially in the areas where we saw a lot of earthworm activity, we were actually measuring in excess of 4 inches of soil. And it appeared to us that we, maybe there were areas where we went down low or so on. But I actually did this quite meticulously, where I measured throughout the whole areas exactly how deep the profile that I added was. But we were distinctly seeing tubes, and if you can see right here, you'll see one of those areas where earthworms are actually moving down and pooping out all this char and compost and creating and deepening the horizons. Didn't stop there though. We submitted a number of samples to the University of Florida Soil Testing Lab. Cost me an arm and a leg, because as I said, I didn't get sponsorship on this. But here's what's interesting that we were finding out. For all of these nutrients that we're looking at parts per million of phosphorus, potassium, magnesium, calcium. We looked at pH. We look at the percentage organic matter. We look at the cation exchange capacity of the soil. And also we look at earthworm counts. For the areas of control, you can see what that is. You can take a quick read of that. The areas where there's compost but no biochar were interesting, because compost definitely helps. But the areas with biochar and compost, we're seeing significant improvement in the ability of the soil to produce crops. And earthworm counts were actually more significant in those areas. And in every one of these areas you look at, you'll realize that the parts per million of phosphorus, these were being absorbed and be able to be released to plant root systems in the soil. But that was a tremendous finding based on what we did here. So I don't know what happened there, but my thing is stuck. Technical help. Yeah. Maybe my time is up. Yeah, I don't know what happened there. Okay. Okay, that's a slide I want. That's okay. That's the slide I need. Okay. All right. All right. 1 second. Yeah, it's moving. Okay. All right. So here's the other thing that we did, both in Haiti and in Florida, was to conduct analysis of variance on these things, so that we were more scientific than just basically general. We wanted to figure out, to exclude other reasons for the areas with biochar performing so well. And what the ANOVA indicated was a strong significance of biochar on the idea of soil creation. Because of all the things that it attracted into that area, the adsorptive capacity was tremendous in terms of how it actually kick-started an ecological environment within the soil. Some of the areas, the communities of practice, there are several of them, but the 4 that I focused on were in Sakala. This is an organization in Cité Soleil called Sakala, right in the middle of Cité Soleil, that participated, an area in Gantia. And forgive my spelling for those of you who are Haitian in the room. I hardly speak French. In Vaudreuil and in Gromont, up in the mountains, where we conducted these exercises. We use the systems that farmers are accustomed to. These are kind of irrigation trenches that the Germans had influenced way back in the early 1900s, when they had an impact on Haiti's development or on underdevelopment, depending on what your perspective might be. But we used these. We actually added our 2 inches of biochar compost in most of these areas. And to kind of simplify the findings, what we're finding eventually was that we were improving soils in most of these areas where you have soils that were cracking up, drying up because of the bimodal rainfall pattern of Haiti. We were actually creating soils that were better amended for the production of both fuel crops and food crops. The result was, in that particular plot there, tremendous. These guys wanted me to come back and do 10 acres. I mean, I don't know where we find the biomass, first of all. Because one of the approaches that, I want to make sure that I pointed this out, that one of the things that we did, we made sure we did, was to go into the markets, the open markets all over, and collected whatever waste we could find, cabbage leaves, whatever, banana peels, stems, whatever, chopped these up, and we made hot compost. We made piles and piles of hot compost. So while we're making biochar, and it wasn't hard to find material for biochar either. All we did was went to the areas where the sugar factories or the sugar plantations dump their bagasse. We chopped those up. We used that to make compost too, but we chopped those up and we made lots of biochar that way. Then we submitted the samples that weren't really good. We really didn't delve in it. However, we found that Leucaena, or lead tree, grew everywhere in Haiti, even on the depleted soils. Grew very, it doesn't require a lot. And some work on Leucaena was done years ago, where I believe sub-organizations within the FAO conducted some work to find that Leucaena actually made really great charcoal. It was one of the best charcoals that they could find. We thought that if it did that, then we could actually use it to make really good biochar. Hence, we actually chopped up the Leucaena at ECHO. We actually used some of the cook stoves. We used one of the cook stoves, and Craig, you'll recognize that. You're in that picture there. You helped me do that. And we cooked a really nice pot of rice in it, because I wanted to figure out, obviously, I'm sure that Haitian housewives are better cooks than I am, but we cooked up a really nice pot of rice in this. We didn't put any legumes in there. But did you taste it? It was very good. All right. It was really the best rice I ever tasted. But what ended up happening was that we were producing from about 1.5 pounds of chopped up Leucaena pellets, as I refer to them, or wood chips. We were producing about 1 pound of biochar. And remember that picture with the GACS analysis that I showed you? When we submitted this, it was the char, the absorptive capacity of this particular char using the cook stove, the T-Lud cook stove, was really off the charts. They couldn't understand. Dr. Hugh McLaughlin and Johannes Lehmann both couldn't understand what was happening. They figured, you screwed something up, Roy. So we actually did it again a couple of times, submitted more and more samples, but it turned out that this actually has a pretty good adsorptive capacity. It was one of the best chars that we created. So I wanted to show this. An IFES, an integrated food energy response, or a biomass biochar value chain, as opposed to the charcoal consumption chain that I showed earlier. You saw the negative portions, the ecological issues related to charcoal. I think that charcoal can be used to great advantage when you consider an integrated food energy systems approach using restorative anthropogenesis, making things like compost and so on. And certainly, we did not discount the idea of making biogas in areas where we could do that. So here's the response to the charcoal consumption chain. So you change the ecologic values, right, to growing high fiber, fast growing species like Leucaena, all right, and integrating food energy so that you're not just growing and then removing biomass and nutrients. You're actually contributing to the carbon in your farm by ensuring that when you cook up your food using wood chips in a T-Lud system, and this can be applied not just at the household level, but certainly on large industrial scales, this can happen. One of the things that we thought was that in the hospitals in Haiti, they could actually have large T-Luds that would work for cooking food and drying clothes and linen, which has always been a challenge in Haiti. And baking bread and so on. But certainly the IFES, where it looks at the idea of energy, can be changed dramatically. Improving agricultural capacity as a result of the things we talked about. And soil and land rejuvenation is important. That will be one of the results. And then biomass, biochar, composting is very important. But here's the other parts. The economic portions still remain, as I showed earlier, in that the charcoal consumption chain is important, even though it's a hidden sector currently. We can actually bring that out of hiding, take it out of the closet, and make full advantage of the important parts of it. So that we have biomass production, we have employment, upwards of 150,000 now that you have actually created some economic opportunities over there. Artisans certainly will have to be trained. So there's going to be obviously a paradigm shift in how people actually see things. So you're changing and moving away from making charcoal stoves to making biochar stoves. That idea must be incorporated in the whole deal. We're not simply importing biochar stoves into Haiti. You're actually making them there. But there are commercial values too. The packaging, the transportation remains and contributes to that. And I think that paradigm shift can happen if there is some kind of political commitment to it, not just in Haiti, but certainly from the vast number of non-governmental agencies that exist in Haiti. So here are the findings to complete this. One is that Haiti's ecological demise has its roots in colonial biomass harvesting. Large companies went into Haiti after 1830, when they forced Haiti to essentially repay, make reparations, and they harvested a lot of trees for shipment to Europe and elsewhere. The other thing is that anthropogenic vulnerabilities and ecological crises are identified. We know where they are, we understand what they are. Energy poverty is equal to food insecurity, and so that there has to be a paradigm shift, or there should be a paradigm shift, to understanding by farmers in Haiti and others that blending the idea of food production with energy production is an important goal and an important way forward. And then an integrated food energy system approach is viable and can be actually expanded upon. Here are the recommendations really quickly. Recognize the biomass energy sector, whether it's charcoal or biomass, but recognize that. Address the knowledge intensity of integrated food energy systems. Incentivize the quicker uptake of integrated food energy systems by making it easier to afford. All right? And then provide rewards to community adopters, people who adopt things that are ecologically important, and provide some kind of incentivization to them. I mean, that's not difficult. I mean, they give a lot of incentives for other reasons. Then provide rewards to community adopters, advocate international policies toward Haiti that include innovations such as payment of biochar, soil remediation credits to communities of practice involved with soil remediation efforts. And then finance habitat-specific afforestation projects, because that's important when you understand that you finance it in a way that recognizes that most of the trees we grow are not in soil. All right? It's in horizons that are not going to sustain those trees. So we don't waste money unnecessarily. Develop community restoration funds. All right? That is where I think the NGO should focus, so that you create jobs and so that there is less of an idea of dependency and more of job creation to stimulate at least the economy. Accommodate ecological investments and trade dynamics in Haiti and elsewhere. And one important thing is to de-emphasize the importance of non-governmental organizations with self-created mandates, because that doesn't help. Here's what I want to point out really quickly here in about 10 seconds, I know my time is getting up there, is that you accommodate the ecological investments and trade dynamics by which biomass resources of indigenous plant organisms flow into Haiti from the Dominican Republic, which is the same island. We concentrate bringing things from Africa, bringing things from Florida. It really doesn't work. It's the same ecological niche. You want to actually look at making sure that you have these kind of trade dynamics between the Dominican Republic and Haiti. There are lots of stuff, if you may, I'm going to ask you to write down this title. Urban Oasis Offers Hope to Haiti's Poor, because I went into Cité Soleil in Haiti, and we worked on a garden there with the Sakala project, that we grew things in containers using compost, biochar, all that stuff. And this was actually featured on CNN in 2014. And I think it's a really good 2-minute video that you'll enjoy. Thank you very much. Appreciate that.